Guess what I be doing for the next 2 months? Hi, have you ever wanted something you didn't need? Because when I saw a video of a trash can that looked like it came from the future, I thought, that is so sick, where can I get one? Oh, right. This is just some proof of concept made for 2017 Japanese Expo. 2017! Almost 10 years have passed, and instead of getting rid of trash they made even more of it and put them on the streets. Oh, but Lidiko, why do you need a trash can when you already have this YouTube channel? Well, the reason is... I can come up with a good reason for wanting one, but it's satisfying and it seems easy to make. So here's the plan. First, we need a trash can that we can modify. And where do we get one of those? That's right. We catch one in the wilderness.
Alright, if we're lucky we might just be able to find one. Wait a second. I found one. We have to sneak up on him. I think he's sleeping. What? I got him.
After we disassembled the creature and removed its plastic parts, we now have 2 metal shells. They have some cosmetic damage, but that's not the main concern right now. Let's start with the lid. I haven't learned how to quantum tunnel my trash yet, so we'll need a large opening on the top, which I'll mark with this compass. As I said, I will mark it with this compass. I think we'll need to bring out the special equipment. Guess what number comes after 1? 2. We can now get rid of the middle and clean the surface. But a knife isn't gonna cut it. Now we can clean the surface with sandpaper to make it look all shiny and new. Although the small dents will remain since I can't do much about them. We do the same for the bin because that just looks nasty. After polishing comes 3. Reinforcement. For the bottom of the bin I'll be using this steering wheel thing to make it resistant to bending. And for the top, these 4 spacers will be pushing against the rim, held down by the inner plastic bin. Now we just secure things down, cover up some holes with aluminum tape, and it's time to 4. Design the moving parts. And by design I mean go onto Thingiverse, search for design, download it, modify it a bit to fit your criteria, and you just save a week of headache trying to figure out how to design something from scratch. But for real though, thanks to the guy whose name I cannot pronounce for this design, it's incredibly well made. For the electronics, I'll be getting a circuit board from PCBWay, today's sponsor. But I'll come back to this later. My 3D printer wasn't big enough to print out everything in one part, so I had to do some nasty plastic welding, then make sure that every single piece could move freely without a lot of friction. Did I forget to mention what I was even assembling? This is an aperture/iris, a circular door if you will, the same mechanism that you can find in camera lenses. It consists of overlapping blades that slide over each other, which control the size of the opening. The problem with most of these on the market is that they don't close fully, which in our case would just let the smell out, so we need our hole to be as small as possible. That's good enough, but I would like my blades to go inward, like this, not like that. Mirroring everything on the y-axis should fix the issue, right? I was thinking that reprinting everything wouldn't be worth it for that small cosmetic inconvenience, but this whole thing is falling apart anyway. I might as well take it apart and salvage some of the parts that I can reuse, like the ring, handle and front cover. Now we just have to do the entire assembly all over again, make sure everything fits and slides smoothly, and after days of work we'll finally have a flip mechanism just how I wanted. What? Hey, you're about to witness me going through the 5 stages of grief in a mere 60 seconds. Enjoy! First I thought, there is no way I did all of this work for nothing. I must have assembled something wrong. I mean, wouldn't mirroring the part also mirror the way the blades close? This cannot be real. I then proceeded to test how stable my desk was when I realized that the only thing that has been flipped was the direction you open and close the iris, not how the blades mesh together. But there must be some easy way to fix this, right? There has to be. After taking a quick nap on the floor and thinking about how I got here, I had two options. I was either gonna give you up, let you down, run around and desert you, or I was going to sit back down to the computer, figure what I did wrong, fix the issue, do everything all over again for the third time, and finish what I started like a real man. Right, Bleedy Call? You're not gonna give up just like that. You're better than this. So what do you say? Are you gonna go back and finish your goddamn job properly? No. Anyway, step number 5. Prototyping the electronics. This doohickey is obviously not going to be hand-powered, so I'll be using this small servo motor to help me out. With just 3 wires you can control the speed and direction of the shaft, which is connected to a gear segment, which is connected to the iris. But look at that! You see, servo motors usually only have a range of about 180 degrees, and in our case, that's not enough. But with a couple of modifications, it's possible to remove these limitations. So I did. The iris can fully close now, so we can move on to the detection. One thing I didn't like in the original is that bulky ultrasonic sensor sticking out at the top. Since I'm going to make mine look more high-end and premium, I need something much less visible, so we have 3 options to choose from. By using a laser diode on one side and a light sensing component on the other, we can detect if something gets in the way of the laser's light beam. It's fast, it's simple, and disappointing. I imagine the detector looking more like something you see in the movies, not like this. Huh. Anyway, it also has no range, which is quite bad, so moving on. These operate with infrared light and have a range of about 10 cm. But as you can see, they're not very stable on their own, so this small code should make them run better. Why does it work so well? It might work well enough, but the detection range is still kinda terrible. By combining the first 2 options, we get a time-of-flight sensor with both high range and good reliability. As I move this ball towards and away from the sensor, I get fast and accurate distance measurements. Just what I want. You know what else I want? A working prototype.
The first prototype finally works. Check this out! We got some power over here. We have some wiring. And we have the code that I wrote myself. So let's say you have some trash, like that. You pick it up, and now all you gotta do is just... Looks like the trash is gone. This thing is so sick, I can't stop playing with this. Yes! Yes!
Now that things work, we can finalize things with the PCBWay sponsorship, who yet again kindly helped this project come to life. I recommend you check them out. Now we have all the parts. So 6. Assembly. I'm going to disassemble the iris once again to absolutely make sure that there won't be a lot of friction when opening or closing it. After tasting the lubricant to make sure that it hadn't expired, I applied it on the moving parts, then permanently welded the front cover to the body. The electronics are important too, I guess. But something wasn't right. Whenever the motor started, it kept going in an endless cycle of resetting the microcontroller. I was panicking for 30 minutes straight before realizing that the problem was the fuse, a component supposed to protect the circuit from destroying itself. I replaced it with a stronger one, but at this point the fuse is completely useless. But hey, at least everything works now. One more dremel cutting session later, I stuck the iris to the lid and finally turned it on. Now it works just how I want, so a few drops of hot glue later. Thanks for watching. If for some reason you want to buy this one-of-a-kind trash can, I'm considering selling it. I never sell my projects because there's only one of each, so they mean a lot to me. But this one just takes up way too much space in my room, so if you really want it, then email me. And that's basically it. Now I can go and edit this whole thing.